Welcome to Bare Metal Machine. I'm Jeff Audia. A little bit of a different background for today's episode, I think you'd agree. This heap here is my 1988 Harley Sportster. Don't laugh at it. The video's not going to be about the motorcycle, but rather a part that I've made for it here in the shop. And it's interesting because it's going to allow me to illustrate a use case for the Cartesian display system that I mention quite a lot, but I've never really shown a complete example of, and that is prototyping. Now, I think that just about anyone that's doing creative work respects that if you're designing something from scratch, that it can take a number of iterations to get it exactly the way you want. Like, for instance, from a mechanical standpoint, the part, it has to fit and it has to solve the problem that it's intended to solve from a mechanical standpoint. And then also from a visual standpoint, you want the part to look artistically and aesthetically the way you intend. Now, it would be awfully impractical to go running back and forth to a CNC machine shop every time you wanted to make another little tweak to your design. Instead, with this system, you can do all those iterations in your own shop on your own time. And once you've reached the end of your iterative process, you are going to be armed with two crucial ingredients that the CNC machine shop's going to need. You're going to have a DXF file that represents the part's final configuration, and you're probably also going to have a fixture to hold the part while they're machining it. Armed with those two ingredients, the machine shop has everything they need. All they got to do is put a cutter path on it, and then they're off to the races. Okay, now the part that I'm talking about in particular for this example is a thing called the Sprocket cover, and it's right here. I'll zoom in on it in a second, but get a good look at the right side of the Sportster engine. Anyone that already knows what a Sportster engine actually looks like can tell immediately that this thing has been chopped quite heavily. In the Sprocket cover, this is the part that I needed to create from scratch. Okay, so here's a better look at it. Back here, this is the sprocket, of course, and you can see that it's not just a cover. This thing actually has some mechanical responsibilities, like there's this link in the master cylinder for the rear brake. Okay, for reference, this isn't my bike, but it's the same model and year. Look at the right side of that engine, and you can see the before and after, the difference between the stock engine and the chopped version. This is a very popular chop for this motorcycle. Okay, here's what the part looks like straight out of the CNC shop. Okay, and this is the part that was made here in this shop using the Cartesian display. Of course, you cannot tell the difference between the part that came from the CNC shop and the part that was machined here manually in this shop using the Cartesian display system. And naturally, because we were both working from the same information, we both used the same DXF file. Okay, but there is actually one important difference between these two parts, and it's regarding the surface finish on these radiuses, okay? You've seen me on other videos where I etch-a-sketch my way around these radiuses in order to machine them, and that is as opposed to a CNC machine, which of course has circular interpolation. And you can see the difference. Let me turn the part up on edge and refocus the camera. Okay, so you can see the little facets that are left behind, when you machine one of these arcs manually, okay? See that? But, for a prototype, it actually is pretty good. Right? This is as opposed to the part that was CNC machined, right? And the arcs, of course, look perfect. But, for a prototype, often it doesn't matter. And actually, even in my case, it doesn't matter further because these parts get painted, right? They get powder coated, right? And that completely covers up all those little facets, right? You can't see them. And I know this part's half the thickness. It's because this was my last prototype that I had that was a ½ inch thick, and this was just one of my earlier prototypes. So I didn't have one in the raw to show that was a ½ inch thick. Now, of course, there's nothing stopping you from hand finishing these radiuses to get them smoother, make them look prettier. it's never going to look like a CNC result, but you could go in there with like a drum sander and hand finish that and smooth them out, as much as you like. But again, for a prototype, it usually doesn't matter. And once again, if it's going to be powder coated, it further doesn't matter, because you're just never going to see it. It looks perfect. It looks exactly like the version that came off the CNC, honestly. Okay, so let me show the fixture that I used to machine this part. Okay, this is the fixture that I used in my shop to machine the part manually on my Bridgeport using the Cartesian display system. And as you can see, it's pretty beat up. It's had a rough life because this part has gone through a few design iterations. And so the way it works is, in my case, I had to use the computerized rotary table, and I put the fixture on the table, and I indicate this edge, which actually has a qualified milled edge on it, and indicate that parallel to the x-axis. And then I indicate this hole here, and that's 0, 0. Okay, and so before I went off to the CNC shop, I happened to have enough material lying around to make a fresh fixture, and so this fixture here represents the final configuration of the part. And so all I did was bring them this fixture and the DXF file, and I just tell them to make this surface parallel to the x-axis, indicate that hole in as 0 to 0, 0, and then they were free to put their cutter path on it, and then they were off to the races in the production mode. So the point of all this is that the Cartesian display system, it did its job. It allowed me to make several prototypes of this part to work through the details of the mechanical properties of the part as well as the artistic attributes of it before going into production. And so you might be wondering, well, how come I haven't shown any machining? How did I actually cut the part? Well, that sort of action has been captured in a lot of other videos, and I didn't feel the need to cover that again. Instead, I think I'll just show some snapshots of the part fixtured up on the machine during the machining process. And besides, a part like this is machined with a great deal of flood coolant, and so it's really difficult to see what's going on anyways, because the part is completely covered in chips and coolant the whole time. Now, in case anybody's interested in how I machined the engine cases for the Sportster engine, I refer to that as a popular chop that people do to this particular bike. Here's a couple of snapshots. This was also done with the Cartesian display system, by the way, and I simply made a fixture that allowed me to hold that awkward engine case and machine away that excess metal. And of course the sprocket cover, which is a separate part from what you're seeing here, I just threw that away altogether and made my own sprocket cover. Okay, so I hope you enjoyed this, and thanks for watching.